Suppose I had some universal set, call it S, and let's say we could denote this set by this. And within that set, suppose I had two sets, set A and set B, which did not share any, they do not share any objects in common, meaning A intersect B is empty. And when this happens, we call these two sets mutually disjoint, um, because their intersection contains no elements and they're mutually disjoint. And when this is the case, then A union B, if they're the only two sets within set S, the universal set, then A union B will give us the entire set S. And if we have this property of these two sets being mutually disjoint and this property of their union being the universal set, then we say that A and B are complements of one another, That is to say that if we had a set A, then we denote the complement of set A as this, where we superscript a small letter C on top of the set that we're taking, that is the complement. And we have these properties, as we just discussed, that the intersection between a set and its complement is going to be empty, and the union between the set and its complement is going to give us S, which will be a universal set, which basically will be the set that contains all the objects that we know are all the objects we're looking for in a specific case. So just by looking at this, we could see one interesting property is that the universal set S and the empty set are complements of each other, right? Because the intersection between them must be empty, because the empty set contains no elements and the universal set is a non-empty set, so it contains elements. So their intersection will be empty because they contain no common elements with each other. But their union is the universal set, because we're taking all the elements in S or in the empty set, which will just be all the elements in S because the empty set has no elements.